So to begin this objective, I'm going to go over first the meanings of enzyme and substrate, just as a little review. So enzyme is a catalyst or protein that helps lower the activation energy of a reaction to make it go quicker, and the substrate would be the reactant that the enzyme is acting upon to help that reaction occur. So it would be in this equation, the substrate would be A, and the enzyme would be acting upon A to produce B and C. So the way that that would happen is that the A would find the A and the enzyme would find each other because of the way that they're compatible for each other, because of the R groups along the enzyme, specifically along the place where the substrate would come in and fit with it, and that place is called the active site of the enzyme, so the place where the substrate and the enzyme fit together. So the R groups along the active site are compatible with the substrate, therefore they fit nicely with each other and they're attracted to each other, and they form this thing called the enzyme substrate complex. And that's pretty notable to know, but it's easy to remember just because it's the enzyme and the substrate forming together to make a complex. So then when this happens, there are different bonds and bindings being made and attractions, such as hydrophobic interactions, hydrogen bonding, dipole-dipole interactions, and ionic interactions, and all of these interactions and bonding and bindings are acting upon the substrate, and it puts a strain on the substrate to produce the strain allows it to produce the products like here. It puts the strain on A to produce B and C, and then once B and C are produced, they no longer fit and they're no longer compatible with the enzyme, so they leave the enzyme, and the enzyme is now open and ready to accept another A that it's again compatible with. So the ideas behind this and the mechanisms behind this began with something called the lock and key. The lock and key mechanism, and that is the idea down here that an enzyme fits with a substrate like a lock and key would. So each have a very specific shape, a very specific fit, and each substrate and each enzyme are meant for one another. And so when they fit with each other, they're able to open the door like a lock and key would, and produce that open door and produce that open thing. But then the substrate and the enzyme like that would produce the products of the reaction. So they would fit with one another, and then another key could come in that's the same. And then in a contrasting view, later came along the Induced Fit Model, which is the idea that the enzyme wouldn't remain the same shape. It wouldn't be like a keyhole the whole time. It would be one specific shape, and then the substrate would come along and change that shape to make it compatible with the substrate, and so then the substrate and the enzyme could combine to form the complex, and the reaction could undergo, and then the products would leave the enzyme, and the enzyme would return to its original shape, such as this. So the real difference between the two is the lock and key would have the enzyme remaining pretty much the same shape, no matter if the substrate was fitting into it or not, just like a keyhole remains the same shape no matter if the key's in it or not. And the induced fit is that the enzyme is one shape, and then when the substrate comes in, it kind of changes shape, and the R groups alter and move around to create that specific shape that the substrate wants so that the reaction can undergo easier.